Okay, so in this unit, we're going to talk about a new type of factoring. We're going to review types that we've already talked about. But the big thing here is there's one type of factoring that we haven't done at all, and then one type that we didn't touch on earlier in the year that you did do in Algebra 1, which is factor by grouping. But it's not a super common method for solving polynomials. You may see it with just general factoring, but it's just not usually used when you're solving high order polynomials, which is going to lead us into solving high order polynomials later in this unit. Okay, so the first thing is, when you are factoring, the first thing that you always check for is GCF. Can get you into big trouble if you don't check for GCF first, because you may miss it. And if you happen to do bottoms up and it has a GCF, that GCF will factor away, which you probably learned in the rational expression unit. If you did bottoms up without taking that GCF out, then you were missing a factor in that problem. So we look at our coefficients and our variables to determine what our GCF is. So our greatest common factor of 12 and 10 is 2. Our greatest common factor of a cubed and a squared is a squared, because both of them contain an a squared. So 12 divided by 2 is 6. A cubed divided by a squared leaves me with 1a. 10 divided by 2 is 5. And a squared divided by a squared is 1. Okay? So same thing. We start with the coefficient. So the GCF is 7. I can take out a maximum of 2 m's because this one only has 2. And then a maximum of 2 n's. So 14 divided by 7 is 2. M to the 8th divided by m squared is m to the 6th. N to the 5th divided by n squared is n to the 3rd. Negative 7 divided by 7 is negative 1. M squared divided by m squared is 1. N squared divided by n squared is 1. Students have a high rate of leaving off that constant at the end if it just happens to be a constant. But remember, you should be able to remultiply and get your original problem. So if you have a monomial times a monomial, then you only have a monomial, whereas this is a binomial. So make sure that once you factor that it will remultiply to get your original problem, okay? So difference of squares is something that we have done. We know that difference of squares factors into conjugate pairs, those opposite pairs, right? So perfect squares are just the numbers squared. So 1 squared, 2 squared, 3 squared, 4 squared, 5 squared, 6 squared, 7 squared, 8 squared, 9 squared, 10 squared, and so on and so forth, right? So as soon as you see one of those numbers in a binomial that is subtracting, it's a very high probability that it's a difference of squares. So notice 9 and 49 are both perfect squares. X squared and y squared are also perfect squares. Check for a GCF first. 9 is divisible by 3 and 9, but 49 is not. So then I would take the square root of the first term, which is 3x, minus the square root of the second term, which is 7y. And the second one is the square root of the first term plus the square root of the second term. So number 4, even though this is a fourth power is a perfect square. So x squared, which means perfect square, right? Perfect square is x to the 4th. So it is a perfect square. However, 72 and 2 are not. So that would either mean it's not a difference of perfect squares, or I have a GCF that I need to take out. So obviously these are both divisible by 2, so I'm going to take out a 2. It gives me 36c to the 4th minus 1. Now I have the difference of two perfect squares. So the square root of this is 6c squared minus 1 and 6c squared plus 1. Conjugate pairs. So obviously this is supposed to be a difference of squares because it's in that section, but it obviously has a GCF that we need to take out because 7, m to the 7th, n to the 3rd, none of these are perfect squares. So my greatest common factor of 7 and 28 is 7. M to the 7th, well, I can only take out one m because this one only has 1. And n cubed means I can take out one n. So 7 divided by 7 is 1. M to the 7th divided by m is m to the 6th, and n divided by n is 1. Negative 28 divided by 7 is negative 4. M divided by m is 1. N cubed divided by n is n squared. Now I have a difference of perfect squares. So remember, something being squared makes it a perfect square. So x cubed squared, power to a power, we multiply. So x to the 6th is a perfect square. So we have 7mn, square root, opposite sign between them. So m cubed minus 2n and m cubed plus 2n. Okay? So I want you to take a look at number 6 and just kind of figure out what you think the GCF is, and then what you think the difference of squares are. And I'll give you just a second, and then I'll work that problem. Okay, so we have then 10w was my GCF, which left me with w to the 4th minus 1, which is the difference of perfect squares. So I have w squared plus 1 and w squared minus 1. Okay? So sum of cubes. So this is the new one. Okay, so perfect cubes are just, we've talked about perfect cubes when we did the radical unit. So 1 cubed, 2 cubed, 3 cubed, 4 cubed, 5 cubed, so on and so forth, right? Okay, so when you see a difference or sum of perfect cubes, okay, so there is a rule that when you factor this, it's the cube root of this, just like it appears, and then you SOPS, what's called SOPS, and it's square the first term of this, opposite sign, the product, plus the square of the last term. This is called SOPS. Okay, so SOPS stands for square first term, and that's of your A plus B term, or A minus B. We'll do difference of cubes in just a second. Square the first term, opposite sign, product of the two things, and plus the square of the second term. Okay? So let's put it into action. So if I'm going to factor this, the first thing I do is get that binomial, which is the cube root of these things. So the cube root of x cubed is x. The sign stays the same, and the cube root of 27, or you can view it as the cube root of positive 27, is 3. Then we're going to SOPS. This is what we are SOPSing. Okay, do not SOPS the original, because you're going to get this huge, these very large numbers and very large powers. And of course, you know, when you're factoring, your powers should not get bigger, they should get smaller. Okay, so SOPS, square the first term, so x squared, opposite sign, so this is a plus, so I'm going to put a negative. The product of these two things, so 3 times x is 3x, always plus the square of the last term, which is 9. Okay? Now, if this factors, you would continue to factor. But I will tell you, 9 out of 10 times, this trinomial does not factor. Now, notice that I didn't say it never factors, because it can factor. Okay? But 9 out of 10 times, this trinomial will not factor. Okay? So then here we have the sum of two cubes. So I get that binomial first. Cube root of m cubed is m. The cube root of positive 216 n cubed is positive 6n. Okay, and then we SOPS. Square the first term, m squared, opposite sign, the product of these two things, so 6mn. Remember that your variables always go in alphabetic order, plus the square of the last term. Here's the thing. Don't forget 6n squared means you have to square the 6 and the n. So don't forget to square both of them. Okay? Number 9, same scenario. So the first thing is 500 nor 4 are perfect cubes. So I immediately think, well, this obviously has to have a GCF or they wouldn't have put it in the sum of cubes section. So I'm going to take out a 4, my GCF. This gives me 125a cubed plus 1. So then I have 4 times, so I get my binomial first, so the cube root is 5a plus 1. And then I SOPs, so square the first term. Now the 4 has nothing to do with it. We're SOPsing the binomial only. So square the first term, 25a squared, opposite sign, so a negative. The product, so 5a times 1 is 5a, plus the square of the last term, which is 1. Okay, so let's move on to difference of cubes. So same process, exact same process. It's just that it starts with a negative in the middle, subtraction. So we're going to be using this more for solving. You're not going to just have like straight factoring very often, but you're going to use this for solving. So I'm going to try and move forward. So it's the same exact rule. You get that binomial, except it's subtraction this time, and then we SOPs that. So squared, opposite sign, product, plus the square of the last term. So the only thing that changes is that your initial sign is negative and your opposite sign is positive. So we'll find our binomial first. So the cube root of x is cube root of x cubed is x, cube root of negative 1 is negative 1. And then we're going to SOPs it. Okay, square the first term, opposite sign, product, so x times 1 is x, and then square it plus square of the last term, which is 1. Okay. So same thing with number 12. Cube root of the first term is 6k. Cube root of the second term, which is negative 125, is negative 5. And we're going to SOPs it. Square the first term, 36k squared. Opposite sign, so plus. Product, 5 times 6k is 30k. And then square the last term is 25. Okay. So 4 nor 32 are perfect cubes. So I know it has to have a GCF. Now you have a couple options here. You can leave it just the way it is and take out a positive 4, or you can take out the negative 4. So we can take out a negative 4 and make this 8h cubed minus 1. Now you could have left it the other way. Would have been perfectly fine. So negative 4. Cube root is 2h. Cube root of negative 1 is negative 1. And then square, or perform SOPs on the binomial. So square the first term, so 4h squared, opposite sign, product, plus the square of the last term. Okay. So trinomials. So trinomials are something that we've done before, but we're going to introduce a little bit of a different problem. It's a quadratic type problem. And if you'll look at number 15, you'll understand what I'm saying. It looks like a quadratic trinomial. The only difference is instead of n squared and n, we have n to the fourth and n squared. But it factors exactly the same way. Just instead of putting n and n, we're going to put n squared and n squared. So then we figure what factors of 24, or negative 24, are going to add to be a positive 2. So a positive 12 and a negative 2. Okay. Number 16, we don't know how to factor a cube unless it's a sum or difference of cubes. So my brain immediately goes, oh, GCF. So we need to factor out a w, and then we get w squared plus w minus 20. And then we have a regular quadratic. So we have w plus 5 and w minus 4. So we have three factors, w plus 5, and w minus 4, which is what we'd expect because we expect three factors, three zeros, because it's a third degree polynomial. Number 17, again, we have that trinomial cubic. We don't know how to do anything with a trinomial cubic, so we're going to factor out a GCF of 2a. So we have a squared plus 19a plus 34. Okay, so we need to figure out the factors of 34. That could be 19. So we have 2a, a, plus 17 and plus 2. Three factors, three zeros. Okay, number 18. Again, we don't know what to do with the fifth power, so my immediate reaction is I must have a GCF. So the GCF is just an x, so that gives me x to the fourth minus 24x squared minus 25. So this ends up being just like number 15. It's a type of quadratic. Just instead of an x, we're going to have an x squared. And the factors of negative 25 that add to be negative 24. Obviously, it's negative 25 and positive 1. So we have three factors, but we still have 5 zeros because we have 2 here, and 1 here. Okay, just to kind of keep things in perspective. So again, we're going to have to use bottoms up here. So I have x to the fourth plus 14x squared minus 15. So again, I'm going to have an x squared and x squared. Remember, when we multiply, we add, so this will be x to the fourth. So I need the factors of a negative 15 that add to be a positive 14. So it'll be positive 15 minus 1 and divide by 3. So I have x squared plus 5 and 3x squared minus 1. Same thing with number 20. Still a bottoms up, so m to the fourth minus 12m squared plus 36. So m squared. So the factors of 36 that are going to add to be a negative 12. So negative 6. Two negatives multiply to be a positive 36, add to be a negative 12. But we have to divide that 9 out. And remember, you have to reduce before you do bottoms up. So this would be m squared minus 2 over 3. M squared minus 2 over 3. Which gives me 3m squared minus 2 and 3m squared minus 2. Which you could write as 3m squared minus 2 squared. Same thing, right? Alright, so let's look at what we have next. So this is the grouping. So the whole idea behind the grouping is that you want to group it so that you end up with the same thing being left in each group so that you can factor again. So for instance, group here and here. So if I take out an x in the first group, I have x squared plus x. Sorry. Should have taken out an x squared. X plus 1 minus, if I take a 4 out, take a negative 4 out, I guess. A negative 4 will give me x plus 1. Now notice that you have an x plus 1 in both of these. So that means I can take out an x plus 1 which leaves me with an x squared and a negative 4. Which we could factor again because this is a difference of squares, but we'll leave it for the time being. So we'll do the same thing here, group and group. So we have x squared will be x minus 1. And then 9, take a 9 out of each one of these would be x minus 1. So then I can take an x minus 1 out, which will leave me with x squared plus 9. Now this one will not continue to factor because there is no sum of perfect squares. It's difference of perfect squares only, and then sum and difference of perfect cubes. So these are already set up to group the way it sits. So I'm going to take out a k squared. That leaves me with k plus 5. And this one I'm going to take out a negative 1. And that leaves me with a k plus 5. So I have k plus 5. If I take out a k plus 5, that leaves me with a k squared and a negative 1, which will factor again because that's a difference of perfect squares, to k plus 1 and k minus 1. So again, set up to group nicely. So I'm going to take out a v squared, and that'll leave me with a 4v minus 5. And I'm going to take out a negative 4, which will leave me with (4v minus 5). So I'm going to take out a 4v minus 5, which will leave me with v squared minus 4, which will factor again because this is a difference of squares. So I have 4v minus 5 and v minus 2, v plus 2. So take a look at 24. So the good thing is you do have to factor this. The only time you're going to see this is 2 places, which is really ironic. The first is in college algebra, and they won't ask you to solve using this method. They'll just ask you to factor by grouping, and it's like usually 1 or 2 problems, maybe on homework, and then maybe 1 on a quiz, but usually not. Usually it only appears in homework. And then jump ahead, way ahead in calculus when you're doing limits. This just kind of gets thrown in as this random skill they expect you to just kind of pull out of the memory bank and do. It's just one of those things. So I'm going to do a 2x to the 4th, which leaves me with x minus 9. And I'm going to take out a 7, which leaves me with x minus 9. So I can take out an x minus 9. And that leaves me with a 2x to the 4th plus 7. Okay, so this is on the back on page 2. This is a review. I'm just going to go very quickly through some of these because I want to get to the solving, which is what you're actually going to be using this for. So remember that a difference of squares factors into conjugate pairs, that a sum of cubes factors, and you get that SOPs. So these are both SOPs, just an acronym to help you remember the steps. So you take the cube root first, square the first term, opposite sign, product, plus the square of the second term. Same thing with difference, take the cube root, and then SOPs, square the first term, opposite sign, product, plus the square of the second term. So how could you tell if you have completely factored the polynomial? Well, it's process of elimination is your best friend, because you only have a few things that you can do. You have GCF, you have quadratic, you have a difference of squares, and sum and difference of cubes. If it is not in one of those categories, then it is factored as far as you're concerned. Okay, now I know we have the factor by grouping, but like I said, it's kind of an isolated skill that just pops up randomly, not as a means of solution, but as a means of just factoring. Okay, so GCF, quadratic, which includes bottoms up, difference of squares, and sum and difference of cubes. It has to fall into one of those categories or it is factored. Okay, so I'm just going to quickly go through some of these. So number 5 is a difference of squares. We have x squared minus 6 and x squared plus 6. The only thing that could possibly factor is here if this was a difference of squares, but 6 is not a perfect square, so we can move on. So number 6, a sum of cubes. So take the cube root first. So 4c plus 1, and then we're going to SOPS it. Square the first term, 16c squared. Opposite sign, product, 4c times 1 is 4c, and then plus the square of the second term, which is 1. Okay. Number 7, a difference of cubes. So take the cube root first, and then SOPS it. Square the first term. Opposite sign, product, 3 times k, plus the square of the last term, which is 9. Okay. Number 9. So it looks like a difference of perfect squares, except 3 and 48 are not perfect squares. So that tells me that if this does anything, then it has to be a GCF. So I'm going to factor out a 3. So that gives me m to the 4th. 48 divided by 3 is 16 n squared. Now I have a perfect square. So I have 3 times the square root and conjugate pairs, right? And this is not a difference of perfect squares because n is not squared, so it's as factored as it can be. Okay? Number 13 is that special case of quadratic. So it is a quadratic, it's set up like a quadratic, and we factor it similar to a quadratic, but it's a 4th degree polynomial. So we're going to do our 2 binomials. Just instead of x, we're going to have x squared. So we want to know the factors of 36 that add to be a negative 12, which we already did earlier, which was negative 6 and negative 6. Which you could write as squared if you so desire. Of course, that's not really factored, but if you were using this as a method for solving, it may be easier to work it that way. Okay. All right, so let's go ahead and move on to solving because we're going to practice factoring within solving. Okay, so basically solving is the same thing. Move everything to one side, factor, and then set each factor equal to 0 and solve for x. Okay, so number 1. So this is not a sum of perfect cubes because this x is not a perfect cube. So my next go-to would be look for a GCF. So I'm going to factor out an x. So I get x squared plus 1 is equal to 0. Okay, so this is not a difference of squares. So I've pretty much factored everything I can factor. So I'm going to set my factors equal to 0. So I have 2 factors. So one of my solutions is 0. That's already done. Didn't have to do anything. So I need to solve here. So I have x squared is equal to negative 1. Square root both sides. So I get x is equal to plus or minus the square root of negative 1. And we know that the square root of negative 1 is represented by I. Okay, so number 2. Before we can do anything else, it has to be set equal to 0. So I'm going to move my 3x squared. So I have 4x cubed minus 10x squared is equal to 0. It's not a difference of squares, it's not a difference of cubes because this is a 3, this is a 2. So I'm going to go with the GCF first. So I know 4 and 2 have a GCF, 4 and 10 have a GCF of 2, and I can take out x squared. So that leaves me with 2x minus 5. So I have 2 factors. 2x squared is equal to 0, and 2x minus 5 is equal to 0. So I have x squared is equal to 0. So x is equal to 0. And 2x is equal to 5. So x is equal to 5 over 2. Now the question becomes, well, this says that I have a third degree polynomial, so I should have 3 zeros. So don't forget that you can have that multiplicity of 2. So 0 appears twice, and then 5 over 2 appears once. So just be cautious that you remember that that 0 does appear twice because it was quadratic. Okay. So number 3, 64 is a perfect square. X to the 4th is a perfect square. So this would be x squared minus 8 and x squared plus 8 is equal to 0. So I'm going to take my two factors and set them equal to 0. Now I know this one wouldn't factor anymore because 8 is not a perfect square. So I have x squared is equal to 8. Square root both sides. I get x is equal to plus or minus the square root of 8. 8 contains a perfect square of 4. Square root of 4 is 2. Square root of 2. There's 2 solutions there. And there's going to be 2 solutions here. So x is equal to plus or minus. So we got to get rid of that negative first. I'm going to bring it out as an I. So then this is going to simplify the same way this did, and I get plus or minus 2i square root of 2. They're very particular when you input this in college algebra, so it would be plus or minus 2 square root of 2 and then I. It's just not clean when you write it that way, so I'm fine with you leaving it like this, but they're very particular in college algebra that the I comes last, so just be cautious. Number 4 is not a difference of cubes, difference of squares, sum of cubes. It's not a quadratic or a form of quadratic, so that leaves me with GCF, which is what I'm supposed to be looking for first. So I have 5x, x to the 4th minus 16 equals 0. And this is a difference of perfect squares, so I have 5x, x squared minus 4, x squared plus 4 is equal to 0. So I have 5x is equal to 0, x squared minus 4 is equal to 0, and x squared plus 4 is equal to 0. So x is equal to 0. Add 4. X squared is equal to 4. Take the square root of both sides, and we get x is equal to plus or minus 2. Similarly, we have x squared is equal to negative 4. So x is equal to plus or minus the square root of negative 4. So x is equal to plus or minus 2i. So notice 5th degree polynomial has 5 solutions. 1, 2, 3, 4, 5. So there's 2 solutions here, 2 solutions here, and 1 here. Always go back and match your solutions to your degree to make sure that your work is correct, okay, that you didn't forget something or add something in. A lot of students, if they have like 5 times x plus 1, you'll say that 5 is a 0 and negative 1 is a 0, but that is not correct, okay? So just be super cautious that your number of zeros matches the degree of your polynomial. So number 5, this is a sum of cubes, so I'm going to take the cube root first, and then I'm going to SOPS it. So square the first term, the opposite sign, product, plus the square of the last term. So I'm going to take my factors and set them equal to 0. So the first one's easy enough, negative 5. Okay, the second one, as I said earlier, this one does not factor 9 out of 10 times, and this one definitely doesn't factor. That's not a big deal. What do we do if it doesn't factor? Well, you can use quadratic formula, completing the square, pretty much anything you want to use, but probably the go-to and the easiest thing to use is quadratic formula. So x is equal to the opposite of b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. If x is equal to 5 plus or minus, so we have probably should have opened the calculator app, but I didn't think of that until just now. So I have 5 plus or minus negative 5 squared minus 4 times 1 times 25, which gives me the square root of negative 75. So I'm going to have an imaginary solution over 2. So I have x is equal to 5 plus or minus. I'm going to pull that I out, and 75 is 25 times 3 over 2. So x is equal to 5 plus or minus 5i square root of 3 over 2. And again, I'm fine with this answer, but in college algebra they are very particular. So they'll want you to do x is equal to 5 over 2 plus 5 square root of 3 over 2i, and x is equal to 5 over 2 minus 5 square roots of 3 over 2i. So this is college algebra. They are super particular. So just be aware that you have to be able to break that apart. Okay? So number 6, I need everything to the same side. So I'm going to move my 4x squared. So I have 8x to the 5th plus x squared is equal to 0. So I have not any of my special stuff, so it has to be GCF. So I have x squared, 8x to the 3rd plus 1 is equal to 0, which now is one of my special things because this is a sum of cubes. So I have x squared, cube root it, so 2x plus 1, and then SOPs it. So square the first term, 4x squared, opposite sign, product, plus the square of the last term. So we have x squared is equal to 0, 2x plus 1 is equal to 0, and 4x squared minus 2x plus 1 is equal to 0. So we have x is equal to 0 twice, so it's 2 zeros. X is equal to negative 1/2, that's 3, and I'm going to get 2 from here, which gives me my 5. So I have x is equal to the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. So I have x is equal to 2 plus or minus the square root of negative 2 squared minus 4 times 4 times 1 is negative 12. So another imaginary solution over 8. So x is equal to 2 plus or minus, I'm going to pull that I out, 4 times 3 over 8. So we have 2 plus or minus 2i square root of 3 over 8, which gives me, everything can factor a 2 out, so 1 plus or minus I square root of 3 over 8. Again, I will accept this answer. College algebra is going to want you to break it apart, okay? Just kind of bear that in mind. Alright, so let's look at one more cubic and one more of the semi-quadratic type. So difference of cubes, so take the cube root and then SOPs it. Square the first term, opposite sign, product, square the second term, plus the square of the second term. So we have x minus 6 is equal to 0, and x squared plus 6x plus 36 is equal to 0. So x is equal to 6, easy enough. This one is going to require a quadratic formula again. So opposite of b, plus or minus the square root, b squared minus 4ac over 2 times a. So x is equal to negative 6 plus or minus 6 squared minus 4 times 1 times 36, negative 108 over 2. So I have x is equal to negative 6 plus or minus I, 36 times 3 over 2. So x is equal to negative 6 plus or minus 6i square root of 3 over 2. These are both divisible by 2, so it simplifies to negative 3 plus or minus 3i square root of 3. Again, I'm totally fine with that answer, but college algebra is going to want you to put x is equal to negative 3 plus 3 square roots of 3i, and x is equal to negative 3 minus 3 square roots of 3i. Just to be clear. Okay, we'll do one more. So number 9. So this is that quadratic type. So it's the 3 terms. The first term is the square of the middle term, so it is that quadratic type. The only difference is, instead of in my binomials putting x, I'm going to put x squared. Then it's a matter of what factors of negative 42 add to be a positive 1. So it'd be positive 7, negative 6. Now, neither one of these factor. This is the sum of 2 squares, which is not a thing. This is the difference, but 6 is not a perfect square. So we have x squared plus 7 is equal to 0, and x squared minus 6 is equal to 0. So I have x squared is equal to negative 7. So x is equal to plus or minus the square root of negative 7. So x is equal to plus or minus I square root of 7. So the other one, we're going to add 6. So we get x squared is equal to 6. Square root both sides, we get x is equal to plus or minus 6. 6 is not a perfect square, nor does it contain a perfect square. So we're done. Okay. So I want you to do, for practice on page 4, I would like you to do number 1, 2, 3, 4, 5, 6, 7. Clearly I didn't think this out, or I could have just said 1 through 7. 8, 9, 10. Just kidding. Okay, 1 through 10. Okay, 1 through 10 on page 4. So this will give you the practice in factoring and the practice in solving. So the key is posted. So my suggestion would probably be to go through and factor everything first, leave space for your work, so that you can kind of get the feel for factoring. Factor, 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 and then go back and solve each one. Okay, and then use the algebra part to solve each one. Okay, so don't forget quadratic formula. Don't forget GCF. Okay.